Hello Math 3 students, this is our second day of Lesson 1. This is Unit 1, Day 2, and we're starting on page 2 of your notes packet, midway down where it says quadratics. Quadratics are functions that have an x squared in them. Let me see if I want to do... There we go. Okay, just want to be able to draw on this. Let's look at this one right here. This y equals x squared plus 8x plus 15. So if I make that one visible, see if I can find, there we go. There it is. I had it all off. So this is a parabola, and that is what a quadratic makes. This is the type of graph that it makes, is a parabola. And I want to start kind of depending more on Desmos. We're going to look at different forms of this type of equation, but I want to start looking more at Desmos because it's really a great tool to use, especially for Math 3. I'm assuming you've used it in Math 1 and 2 also. But for Math 3, we're really going to depend on Desmos a lot. Of course, it's on your exam, so you have the built-in calculator on your exam that you can use. But just want to show you, if you graph this x squared plus 8x plus 15, you can click on the vertex. You can also click on the points that are the x-intercepts. And if you remember, x-intercepts, zeros, roots, these all mean the same thing, so you might hear them called one of those three things. You can also click on the y-intercept up here, is 0, 15. So all of these points, anytime you graph a parabola on Desmos, you can click on any of these points and get those points. So let's go back to our notes, the starting of our notes. Let's see. Here we go. Okay, so halfway down page 2, you have the beginning of the quadratics section, and I want to just show you the different forms that we could write quadratic equations in. One of them is called standard form. There's intercept form. You might also see this called factored form. And then there's vertex form. We don't see vertex form a lot, but I'm going to show you what it looks like, and I'm going to show you how you would get that. Standard form, I'm going to do these in different colors. Standard form looks like this. You've got y equals, and it might be y or it might be f of x or g of x or anything of x. Y equals, and then you have ax squared, so some number a times x squared, plus bx plus c. And we would use this a, b, and c mostly for quadratic formula. If we were going to use quadratic formula for something, we would put it in standard form and take a, b, and c and fill those in for quadratic formula. You've got a chart down under yours, and we're going to get to that in a minute, but I wanted to show you the different forms. Standard form, the way you find standard form, if you've got one of these other ones, is you multiply everything through. And I'm going to show you how to do that, but just write down this for standard form right now. Now, factored form or intercept form is going to look like this. You would have y equals, and then you'd have your a on the outside. Your a is that vertical stretch or compression, horizontal stretch or compression. It's kind of like the slope would be, but it doesn't really have a slope if it's a parabola. So that's what the a is. And we'll talk about how to find the a when we need it as well. And then you've got x minus some number p times x minus a number q. Now, one of the things I want you to understand is if you're given intercept form, you can find the x-intercepts. That's why it's called intercept form. So the x-intercepts, the way you could find those is to set this up equal to 0 and set this up equal to 0. So x minus p equals 0 will give you the x-intercept, and x minus q equals 0. So whatever's in these parentheses, and I'm going to give you an example. So let's say you had, let's see, y equals 2 times x minus 4 and x plus 3. What you'd do is you'd set up each one of these equal to 0. So x minus 4 equals 0, and x plus 3 equals 0. And that way, if you add 4 to both sides and subtract 3 to both sides, x would equal 4 and x would equal -3. So those two numbers, 4 and -3, would be your x-intercept. In other words, over here, your x-intercepts are -5 and -3. Let me go back over here. I'm going to write on this screen again. Okay, so over here, your x-intercepts would be -5 and -3. So that equation, if it's not, this is in standard form, but if it was in factored form, it would be y equals, and then there might be some a. I don't think there is, because there's an x squared there and there's no a. So it would be x plus 5 and x plus 3. So that when you set up x plus 5 equal to 0, you get x equals -5. Well, there's that -5 right there. And then x plus 3 equals 0, x would equal -3. I don't want to get too much into that because we're going to talk about that when we get to going between, between the forms, but I just wanted to show you that real briefly. Okay, going back to vertex form, let me get a different color here. Vertex form looks like this. It would be y equals, you have your a again, x minus h squared plus k. The vertex, you can pick out the vertex of the parabola by taking the opposite of h, so the opposite of this thing right here, whatever that is, the opposite of h, and then k. And another example of that, go over here and see if there's one on this. Let's see. Oh, here's one right here. So this one, for example, and these are all on your chart too. Let me do this one more time. Okay, so this example here, I'm going to make that one invisible, the blue one, and I'm going to do this one in purple. This example, the vertex, I can tell by looking at this equation that the vertex is at, and we'll take the opposite of this right here, so that's -1. And then I'm just going to look at this number right here, which is -6, and just take that one as it is. So the vertex should be -1, -6. Well, let's see. Yep. If we touch that vertex right there, we see it's -1, -6. So this one is in vertex form. So let me erase that. So let's look at these examples right here. And these are, again, are in your chart. I just want to look at them and talk about what form they're in. So this one's in standard form. This first one up here is in intercept form or factored form. This one's standard. This one's going to be in vertex. This next one is also in vertex form. This one's standard form. And this one's in intercept or factored. And then the last one down here is in vertex form. So these are the different forms that they can come in again, and we're going to talk about how to go from one to the other, how to convert an equation from one to the other. So let me get rid of this one more time and go back to our notes, and let's look at your chart. So this is the very top of your chart. The top of your chart, you are given intercept form. And if we look over at Desmos again, this is, should be this one. Let me see. 2x minus -2x minus 4x plus 3. Okay, so let's go ahead and identify. We're given intercept form, so let's identify what our zeros are. Again, if you want to write this somewhere, maybe down at the bottom of your page, zeros equals x-intercepts, also equals roots. So these words are used interchangeably. So if you hear me say zeros, x-intercepts, or roots, I'm talking about the same thing. These are all where the graph crosses the x-axis. Okay, so it's all where y equals 0 or where it crosses the x-axis. So the way I find this, the way I find the roots, or the zeros, or x-intercepts, is to set this up equal to 0 and set this up equal to 0. X minus 4 equals 0. X plus 3 equals 0. Well, essentially all I'm really doing is taking the opposite of this number and the opposite of this number, and that gives me these zeros. So let's identify those. The zeros, or where it crosses the x-axis, are at 4 and negative 3 on the x-axis. Let's go back over here and look at it. Okay, so this first one, if I touch the graph at the x-axis, I get negative 3 and 4, and I believe that was what we said the zeros are, negative 3 and 4. Okay, the way I can change this into standard form, what I have to do is I have to multiply all of this together. So I'm going to get a new page and show you how to do this. You can do this on a separate sheet of paper. You can do it somewhere on your sheet. It doesn't matter. So I've got negative 2, x minus 4, and x plus 3. First thing I'm going to do is I'm going to multiply these two binomials together. If you need to use box method to do this, that's perfectly fine. I'm going to show you one time with box method, x minus 4 and x plus 3. Okay, so with box method, we put each of the binomials, one on the top and one down the side, and then we multiply what lines up with each box. So x times x is x squared. Negative 4 times x is negative 4x. 3 times x is 3x. And negative 4 times 3 is negative 12. So then we rewrite all of this left to right, top to bottom. Now, the thing is, I can see that these two items right here, though, are like terms. So I can combine the negative 4x and the positive 3x and get negative 1x. I still have my negative 2. I haven't multiplied that in yet. I've multiplied the x minus 4 and the x plus 3, though. I got x squared minus 1x, which is just minus x, minus 12. Now I have to distribute the negative 2 in to the parentheses. So I'm going to do that. Negative 2 times x squared is negative 2x squared. Negative 2 times negative x is plus 2x. And negative 2 times negative 12 is plus 24. So that is standard form. This is what I would write for standard form. All right, so standard form for this one, again, y equals negative 2x squared plus 2x plus 24. So to get standard form from either intercept or vertex form, it doesn't really matter. What you're going to do is you're going to multiply everything. So we can just write this up here. We need to multiply everything together to get standard form. Okay, before we look at vertex form, I want you to look at the next item down on your chart. You have, this is standard, and then the center again is intercept, and then this is vertex. So before we look at vertex, let me get rid of that. Before we look at vertex on this one, which we'll come back to it, I want to look at going from standard to intercept, because we just went the other way around. We went from intercept to standard. I want to look at going from standard to intercept. Intercept form means factored form. Okay, I'm going to write this down here. Again, you can write it. You know what? I'm going to write it right here because I think I can fit it in here. What I need to do is I need to factor this trinomial. Now, you did factoring trinomials. I know you did them in Math 2. You should have probably done them in Math 1 a little bit too, but you did a lot of them in Math 2. If you don't have anything in front of this x, it's actually pretty easy to do. So we're going to factor this trinomial into two binomials, to two expressions that have two terms. We're going to have an x here and an x here. We might have a plus and a plus. We might have a plus and a minus. That I don't want you to worry so much about. What I want you to think about, though, is look at the 15 and look at the 8. I need something that when I multiply it, I get 15. So 15 equals something times something. And 8 equals the same two numbers plus each other. Okay, so I need a factor pair for 15. I need something times something that equals 15. Well, 15 times 1, but when I add 15 plus 1, I don't get 8, so that won't work. 5 times 3 equals 15, and 5 plus 3 equals 8. So that would work. Well, that's what goes in here, and they're both positive numbers, x plus 5, x plus 3. So this is actually intercept form. We're going to rewrite this over here, but this is my factored form. So I've just factored this trinomial. If I multiplied it all back together, I would get this again. I would multiply the x times the x and the 5 times the x and so on and so forth. I put it in box method, whatever. So the intercept form for this standard form is going to be y equals x plus 5 and x plus 3. Where the zeros, and I just want to identify the zeros on all of these. I'm going to take the opposite of this number, -5, and the opposite of this number, -3, and those are the zeros. And if I go over here to Desmos, and I look at that one, this was standard form. We just put it into factored form. I should see that my x-intercepts, or my zeros, are -5 and -3. I'll go back over here, -5, -3, which means this is going to be x plus 5 and x plus 3. Okay, go back up to the one above that, and let's look at vertex form. So intercept form, what you would do, write this on your chart, is factor the standard form. Okay, so you'll factor the standard form. For vertex form, what I want you to do is I want you just to look at Desmos. Look at it on Desmos. Find the vertex. Okay, so let me show you what that looks like. So let's go to the first one. That was the first one. We have it in factored form. But what we can do is we can look for the vertex. The vertex here is 0.5 and 24.5. Okay, so then what we would do is take that is 0.5 and 24.5. That is going to go in that formula, y equals, now the a stays the same, the a doesn't change, so I still have that -2. In the set of parentheses, what goes in there is the opposite of this number right here. So x minus 0.5, and then it's always going to be squared. And then this number is going to get added to the end. Okay, so it looks like this, and again, the vertex is going to be the opposite of this, and then this number, which is what we did, the opposite of -0.5 and 24.5. That's the vertex. So if you just go over to Desmos, graph it, look at the vertex, you can write it in vertex form. Okay, the next one, I'm going to make that one visible. So this is let's see. Make it so I can write on it one more time. Okay, so that's the x squared plus 8x. So let's find the vertex. If I click on the vertex, it's -4 and 1. Okay, so this is what it's going to look like. Vertex form, y equals. I don't have an a value, or the a value is 1, so I don't need that. If you put a 1 right there, it wouldn't be wrong. X, and then the opposite of the -4, so x plus 4, and then my squared goes there, and then this number just goes on the end, -1 or -1. So then my vertex again, -4, -1. So let's go back over to our chart. Let's see, here we go. So this one, vertex form, I graphed it, and I just want you to graph these. I don't want you to worry about how to convert them or anything. If you just graph them on Desmos, find the vertex, use the same a, which there isn't one here, it's just a 1. So again, it's going to be y equals, this is a 1, so we don't need it, x plus 4 squared, and I think I put mine wrong on my key. It should be -1. I put +1 on my key. -1. So again, let's identify the vertex. It's going to be -4, -1. Okay, whoops. All right, moving on. The next one, we have it in vertex form. So what I will do first is I'll put it in standard form by multiplying through. So let's see, well, let's identify the vertex first while we're here. The vertex is the opposite of this, so 5, and then this number, -4. Okay, so on a clean sheet of paper or on your notes somewhere you can do this. So I need to multiply this out and get standard form. So my standard form is going to be here. So what I need to do is x minus 5. X minus 5 squared is just x minus 5 times itself. Minus 4. Okay, so if I were to put this in box method, x minus 5, that's x squared, -5x, -5x, and 25. So that's -10x when I add those two together. So I have x squared minus 10x plus 25. Don't forget about your minus 4. So that gives me x squared minus 10x plus 21, because I'm just going to combine these two things. Okay. Okay, sorry, I should have written that over here. X squared, actually let's write y equals. Let's don't forget about the y equals. Y equals x squared minus 10x plus 21. Okay, intercept form. Sometimes you might be able to go graph it and look at the x-intercepts. I'm going to go ahead and just factor this one. Y equals, I'm going to have two binomials. And I need a factor pair. I need 21 equals something times itself, and 10 equals something plus the other thing. Because I've got a negative here, I know that both of these numbers need to be negative, and I'm going to be using -7 and -3, because -7 times -3 also equals +21. So this is going to be x minus 7, x minus 3. Well, let's go back to Desmos and look. Well, I think it's this one. No, wait. It is this one. Okay, so I have 3 and 7 are my x-intercepts. And I've got x minus 7 and x minus 3. If I set both of those up equal to 0, my zeros, I find out, are the opposite of this, +7, and the opposite of this, which is +3. Okay, so we did 3 of these together, and we will do the rest of these tomorrow during class. So I'm going to leave these last 3. You're welcome to try them at home if you want, but we're going to move on to page 3, because if we don't, I'm going to run out of time anyway. And I'm going to do one of these with you, and then I'm going to leave the other one for class tomorrow as well. Okay, so we have the equation y equals -1/4 x plus 3 quantity squared plus 1. This is in vertex form, so I can already look at I can tell what my vertex is. This is underneath your graph, and the x-intercepts thing got cut off a little bit, so you can write x-intercepts underneath it or whatever. So the vertex, I can already tell what the vertex is. The vertex is going to be at the opposite of this, which is -3, and this number, which is 1. Okay, so that's the vertex. The axis of symmetry, let's go over and look at it. This is this one. Okay. So that's the one with the -1/4 in it. The axis of symmetry is where a vertical line would cut this thing in half, and that's always at x equals something. So a little hint, it's always whatever the x value is on a parabola. So it is at, the axis of symmetry is going to be at x equals -3. It always matches the x value in the vertex. Okay. The y-intercept, we can go back over here again. Look at Desmos. The y-intercept is right here. It's 0, -1.25. So I'm just going to look at that on Desmos. Okay, it opens in a downward direction, and we know that because this A value right here is negative. So it opens down, and we'll put in parentheses A value negative. It has a maximum because it has a top point, so to speak, and that's right here. The maximum, it either has a maximum or a minimum. If it opens down, it has a maximum. And that point matches that y value. So the maximum is at, let's say, y equals 1. The domain, actually, let's go ahead and sketch it before we do that part. So we have a vertex at negative 3, 1. We have zeros at negative 5, negative 1. So let's do that. Negative 5, there's a 0 right there. And what was the other one? Negative 1. Okay. Negative 1, okay, and then my maximum or my vertex is at negative 3, 1, so that's negative 3, 1 right there. So I've got 3 points. I can kind of sketch it. So it's going to be kind of like that. It's kind of a fat parabola. So I just need a little sketch. That's all I need. So the domain is all the x values that it could possibly be. Well, the domain, you look at whether it goes forever in the left direction and in the right direction. It does. So the domain is going to be all real numbers or negative infinity to positive infinity. So the negative infinity is, does it go forever left? Yeah, it does. It keeps going. Does it go forever right? That's the positive infinity for the domain. Domain is, you're looking at the x values. The range, you're looking at the y values. Well, it does go forever in a downward direction, but it doesn't go forever in an upward direction. It stops right there at the maximum. So the way we would write that is we would write negative infinity up to 1, and we would use this notation of a bracket because that means that the 1 is included in all those numbers. And the x-intercepts, we already said those are at negative 5. We'll put negative 5, 0, and negative 1, 0. Okay, so for a lot of that, we just looked at Desmos. And that's not a problem. If you have Desmos in front of you, use it if you can. Okay, the next one, we're finish this one in class tomorrow. Let's go ahead and look at, actually, let me see. Okay, guys, so what I want you to do is skip number 8, A, B, and C. We're actually we do more of that when we do the polynomials unit anyway, so I'm going to skip that part because it's not really important for right now. Look at number 9. I think I graphed this one on Desmos also. Let me see if I did. 7b squared. Oh, no, I didn't. Okay, it doesn't matter. We can factor this one real quick. So if you see something like this where we've got this trinomial, we need to factor it. We're going to end up with 2 binomials. But the first thing we can do is, if you notice, 7, 35, and negative 42, they all have a factor of 7. So I can actually just divide everything by 7 and get b squared plus 5b minus 6 equals 0. And then I just need to think about that 6 and the 5, and what multiplied together gives me 6, but then subtracted gives me 5, or added gives me 5, or whatever. So my 2 binomials are going to be v plus 6 and v minus 1, because that 6 times negative 1 gives me that negative 6, and 6 plus negative 1 gives me that 5. So then the roots, or the zeros on this one, would be 6 and, excuse me, negative 6 and 1. So those are the roots. V equals negative 6 and V equals 1. All right, the next one, number 10, I would just graph this one. Let me see if I graph this one. Actually, I didn't. That's fine. So I would just graph this one. 0 equals, and then again, I can also divide all of these by 2. They're all even numbers. X squared minus 4x plus 3. I did graph this one. Here it is. Okay, and then what we're looking for is the x-intercepts, or the roots, and I can just touch on those. They are 1 and 3. So again, if you can use Desmos, use it. So x equals 1 and x equals 3 on that one. Quadratic formula. This one, we wouldn't be able to graph this one. I'm going to skip this one as well. I might come back to it tomorrow during class. I want to look at number 13. I did graph this one. It's a word problem about a rocket, and so this rocket takes off, and here's the parabola that it makes. and it's really hard to see. What I wanted to show you though is that, see how long that is? What you can do if you get a parabola that looks like this, and see there's the top of it right there, you can go over here to this wrench, and I'm going to change the y-axis. I think I can change the y-axis on this one. Okay, so I changed the y-axis and it made it a little bit easier to look at. So now I can zoom in and look at the different points. So what it asks us, and I know I'm over 30 minutes, I'm almost done, is it says this function simulates the path of a rocket that's launched at a science competition. In the equation, h is the height of the rocket and d is the horizontal distance in feet. At the point of impact with the ground, what is the horizontal distance the rocket has traveled? So let's go back and look at the graph. So the rocket is launched, and it's launched here. This is ground. The x-axis is always ground level. So it's launched and it goes up in the air and then it comes back down, and where it hits the ground is right here at 44. So that would be the distance that it's traveled. The horizontal distance that it's traveled is from 0 to 44. So your answer here would just be 44 feet. So we really just had to look at the graph. And then it asks, what's the maximum height of the rocket? Well, that's going to be the vertex of the parabola, right? So if we go up here and we click on the vertex, we see that the maximum, the y value is the maximum height. So that's 2420. So our answer here would be 2,420 feet. Okay, so we skipped a couple of things, but I will get to some of them tomorrow at the beginning of class before you start your classwork. The ones I don't get to, you're not responsible for.